Welcome to Engineering Lessons. In this video, we'll be discussing about indices, and purely they are exponents of numbers or variables. I will be looking at what this exponent do to these numbers, and variables we call bases. So an expression of these indices in numbers, which collectively we call powers, can be given as a raised to n. So we'll call this a raised to n. This then can be expressed in the following way, which is a times a times a, and times continuous until we have written this a n times. So an example of this can be, let's say, 2 raised to 3. Okay, so in this case 2 will be called a base and 3 will be called an exponent. We'll be writing the base a, which in this case is 2, n times. Okay, in this case our n here is 3. Okay, so we'll be multiplying 2 n times 2 and 3. So well, the product of these three entries there therefore is 2 times 2 will be 4, and further times 2 will be 8. So therefore 2 raised to 3 is 8. So another rule in indices can be given as a raised to n times b raised to n. So in this case you can see that we have two different bases but the same exponent. So it's possible to collect this base together, which is a times b and the whole raised to n. If you were given this expression to start with, which is a times b raised to n, it is also possible to decompose it into this form, which is a raised to n times b raised to n. So an example for this can also be given, building on the previous example. 2 raised to 3, 3 raised to 3. Okay, so in this case we are given different bases but similar exponents. So the form we are given is this form, so we can bring this together. This will be 2 times 3 the whole raised to 3. So this, you can have the product of this, which is 2 times 3, that will be 6 raised to 3. Now, as you've said, if we had the other form given, which is 2 times 3 the whole raised to 3, the same form as you have here, and then you will be able to decompose that into this form. So this is writing in such a way: 2 raised to 3 times 3 raised to 3. So we have kept the bases the same and distributed the exponent to both of them. So in this case, if we do this independently, you'll have 2 raised to 3 will be 8 times 3 raised to 3 is 27. Purely because this 3 raised to 3 is multiplying 3 times. So you have base 3 and the number of times that you will multiply the base, which is 3. So in both cases, therefore, the solution will be the same, which is 216, and this will be 216. We'll continue with another rule in indices. So if you had a raised to n times a raised to m, this would be written The base are the same, so we'll add the exponent n plus m. So in the same way, if you are given the other form, which is a raised to n plus m, you could then again decompose this into a raised to n times a raised to n. Okay, now let's have another example. Let's have 2 raised to 2 times 2 raised to 3. So in this case we have similar base but different exponent. So what we are saying is this is equivalent to saying 2 raised to 2 plus 3. Or in other forms, if you had 2 raised to 2 plus 3, you would have decomposed this into 2 raised to 2 times 2 raised to 3. So this will equal to 2 raised to 5. That will be 32. Okay, so let's finish this. 2 raised to 2 is 4 times 2 raised to 3 is 8. So 4 times 8, and the product of this is also 32. Okay, and let's continue with another rule and a simple example again. So in this case, let's see a raised to n over a raised to m. So in this case, you can write the base and have the exponent expressed as n minus m. So whichever exponent in the numerator minus exponent in the denominator. Let's have an example here again. Example. So if our example, let's say, is 2 raised to 4 over 2 raised to 2. So we have similar base and different exponents. So we're saying that this can be expressed as 2 raised to 4 minus 2. So which is 2 raised to 2, 4. We could have gone directly by calculating this, which is 2 raised to 4 over 2 raised to 2. So in this case, 2 raised to 4 is 16, divided by 2 raised to 2 is 4, and of course 16 divided by 4 is 4. Okay, so we still have similar results. So let's look at another rule. A raised to n, the whole raised to m. So in this case, that's equivalent in saying a raised to n times m. We will take another example. So let's have 3 squared, or raised to 2, the whole raised to 3. So this is saying that we can take the base 3, so we can multiply the exponents, and this equals 3 raised to 6. Use a calculator to do this, so I'll have 729. Okay, so you would have the same result if you calculated the other way around, which is just do the brackets first, which is, that will be 3 squared, which is 9 raised to 3. Yeah, that is 3 squared, which is 9 raised to 3. So 9 raised to 3 would be 729. Another variety you can really give is a variety of, for example, of this, which is a different base and similar exponent in division. So that can be written as a raised to n over b raised to n. So in this case, you can divide the base a raised to b and raise it to the same exponent, which is n. So example, okay, that could be, let's say 4 raised to 2 over 2 raised to 2. So we have different base and similar exponent. That can be written as 4 over 2 the whole raised to 2. 4 divided by 2 is 2, then raised to 2, which is 4. Another variety to rule 5, it will be a raised to k. So where k equals n times m, then a raised to k can be rewritten as a raised to n times m. So there are some important applications that you can use this property. An example could be, let's say, 2 raised to 9. That can be rewritten as 2 raised to 3 times 3, because now 9 can be expressed as 3 times 3. Okay. Other examples can be, let's say, 4 raised to 12. So we can rewrite this as 4 raised to 4 times 3, which also can be written as 4 raised to 2 times 6. Alright. So by applying the principle that we have learned earlier, it's also possible to expand this into further expression based on the type of mathematical procedure that we are following. And therefore, we have seen some important properties of indices. First one is this fundamental rule of indices. Okay, and the second is the product term involving similar exponents, and the third one is also a product term between powers involving different exponents, and again a quotient term involving different exponents. A power which has been raised to another exponent, and a quotient form involving a similar exponent and different base. Again, a power whose exponent can further be expressed using product terms. Thank you very much for attending this session, and please continue expanding your knowledge by watching the rest of the videos, and hopefully the skills that you have learned here will be very much crucial when it comes to other topics in this series of engineering mathematics and the rest of engineering lessons. Thank you very much.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment and subscribe, and don't forget to click the notification bell.